The rainforest at night is alive with a soft static, a murmur of unseen wings, the slow drip of condensation, the rasp of cicadas threading the air. From the canopy, pale shafts of moonlight cut through the thick foliage, illuminating a scene of strange violence. A mound, seemingly inert, suddenly erupts, a termite nest torn open from the side, fragments of earth tumbling like brittle bark. From the ragged wound, insects pour in frantic clouds, scattering into the night in waves of chemical alarm. At the center of this commotion stands a figure that looks out of place in the chaos. A small, golden-furred anteater, tail curled like a question mark, nose buried in the living stream of termites. This is the tamandua, an animal whose life depends on stealthy incursions into the world of the unseen empire. The tamandua is not built like the predators most imagine. Its head is narrow, almost tubular, with no teeth to grind or shear, and its vision is poor, unable to make much sense of the fine details that flicker in moonlight. But this weakness is deceptive. What the tamandua lacks in speed and eyesight, it makes up for in specialization. From deep inside its elongated skull, a tongue nearly 40 centimeters long lashes into the nest, coated in a thick, adhesive saliva. Each flick of this living ribbon snares hundreds of termites, sweeping them into the animal's mouth in a steady rhythm. In the time it would take a jaguar to stalk a deer, a tamandua can consume thousands of insects, dismantling what might otherwise be an unstoppable force of collective engineering. In the Amazon, termites and ants are more than background life. They are architects and farmers, shaping soil, recycling wood, and constructing empires that dwarf mammalian societies in both population and organization. Left unchecked, their colonies could spread uncontested, stripping the undergrowth of nutrients and altering the balance of entire habitats. The tamandua exists in the quiet margins of this war for dominance, an infiltrator designed to keep these insect civilizations from overrunning the forest. Its role is less dramatic than that of the jaguar or the anaconda, but no less vital. By thinning the superorganisms, the tamandua prevents a collapse of diversity. The body of the tamandua reflects this ecological assignment. It is strong but not heavy, weighing little more than 5 kilograms, light enough to move through branches without snapping them. Its forelimbs carry long, sickle-shaped claws, sharp enough to rip into wood and earth, but also used in defense. When threatened by an ocelot or a harpy eagle, the tamandua will rear onto its hind legs, tail braced against the ground, claws raised like daggers. In this posture, it resembles a small gladiator, comical at first glance, but capable of slashing deep wounds into a predator's face or wings. More often, though, those claws serve a subtler purpose, breaching the fortresses of ants and termites that would otherwise repel smaller predators. It is in the treetops where the tamandua shows its full range of adaptations. By day, it rests in hollows or tangled vines, curling its tail around branches to secure its grip. By night, that same tail functions as an anchor, freeing its hands for excavation. This arboreal agility allows the tamandua to raid nests high above the forest floor, targeting colonies that are inaccessible to ground-dwelling anteaters or other insectivores. The rainforest canopy is a patchwork of opportunity, and the tamandua moves across it like a careful thief, probing for weak spots in the architecture of its prey. The act of raiding a nest is not random hunger. It is a form of population control disguised as predation. Termites, though crucial for recycling organic matter, can destabilize tree roots when their colonies grow too large, leading to collapses that open gaps in the forest structure. By keeping colony numbers in check, tamanduas indirectly maintain the integrity of the canopy itself, shaping the architecture of the forest in ways that few observers would suspect. The predator-prey relationship here is not simply about survival. It is about balance, a feedback loop where one small mammal restrains billions of insects that could otherwise rewrite the very geography of the ecosystem. The tamandua's sensory world is tuned to this mission. Its sense of smell is acute, capable of detecting the pheromone trails of ants or the faint musk of termites buried under bark. This olfactory map replaces the need for vision, guiding the animal through darkness with precision. Its metabolism is adapted to the peculiar diet it consumes. Insects that are rich in protein but low in fat and water. To survive on such fare, the tamandua must feed constantly, breaking into dozens of nests in a single night. Each raid is brief. Lingering too long risks retaliation, as soldier termites and ants can deliver painful bites or chemical sprays. Evolution has honed the tamandua into a hit-and-run specialist, a creature that thrives on speed, precision, and withdrawal. Even its fur carries a defensive adaptation. Coarse and dense, it shields the skin from insect bites, forming a barrier that frustrates swarms. This natural armor means that even as termites climb in a frenzy across its body, their jaws rarely find purchase. The coloration of the coat, pale gold with darker markings along the shoulders, provides a muted camouflage among lichen-streaked branches and patches of moonlight. The animal becomes part of the forest fabric, moving unseen except for the sudden commotion of a nest erupting under its claws. But the tamandua is more than an insect thief. It is a keystone regulator in miniature. Scientists studying termite populations in regions without tamanduas have found unusual spikes in colony density, followed by visible stress in local plant communities. By keeping insects in check, the tamandua indirectly protects the seedlings of trees, the roots of vines, and the stability of canopy corridors used by monkeys, birds, and reptiles alike. Its influence radiates outward, invisible but profound, proof that even small, solitary hunters can act as architects of balance. The life of a tamandua is solitary. Each night, an individual may cover several kilometers, winding between ground and canopy in search of fresh colonies. By dawn, it curls back into itself, tail wrapped tightly, body pressed against bark, vanishing into the texture of the forest. Its rhythms are the opposite of the larger predators, avoiding competition and relying instead on niches of time and prey overlooked by others. This nocturnal schedule may have evolved as both a defensive measure against daytime raptors and as an opportunistic strategy to raid nests when insect defenses are sluggish in the cooler night air. From a human perspective, the tamandua's existence can appear almost invisible. Unlike jaguars, it does not roar or leave dramatic claw marks on trees. Unlike toucans or macaws, it does not add bursts of color or sound to the canopy. Instead, its presence is measured in absences, fewer termites overrunning a tree, fewer ants spreading unchecked across the understory. The tamandua's role is a negative space in the ecological canvas, a reminder that not all influence is loud or visible. Some creatures shape the rainforest most powerfully through what they prevent rather than what they create. And yet, in this restraint lies an irony. The tamandua is at once delicate and formidable, awkward-looking but finely tuned, dependent on colonies that can overwhelm it if given the chance. It is an infiltrator that survives by balancing on the edge of risk, raiding, consuming, withdrawing, always a few moments away from being outnumbered by its prey. Its survival is proof of evolution's strange bargains, where vulnerability becomes strength and specialization leads not to fragility, but to resilience. As dawn breaks and the forest stirs with parrots and howlers, the tamandua retreats, its work done for the night. Behind it, the torn termite nest remains, half collapsed, its population reduced, but not destroyed. In time, the insects will repair the breach, rebuild their walls, and recover their numbers. But the balance has been nudged back into place, the empire restrained for now. The tamandua, unseen in its hollow, has shifted the invisible weight of the forest scales once again. The river is calm in the early morning, its surface a sheet of bronze catching the first glow of the rising sun. On a half-submerged log, dozens of shells glisten like wet stones, their rounded backs arranged in a tight mosaic. Amazon river turtles bask shoulder to shoulder, silent and immobile, warming their blood under the newborn light. To an observer, they appear unshakable, miniature relics of a prehistoric age, impervious to the world beyond their shells. But then, a heron's shadow glides over the water, and the illusion of permanence breaks. In an instant, the log erupts into splashes as turtles tumble into the river, vanishing into the opaque green below. Their retreat is not panic, but instinct, a reflex that has safeguarded their kind for over 200 million years. For turtles, survival is measured not in seconds or seasons, but in the deep currency of time. The Amazon river turtle, Podocnemis expansa, belongs to an ancient lineage that once swam beside dinosaurs. Today it is the largest freshwater turtle in South America, stretching over 70 centimeters across its domed shell. Though formidable in size, its life is defined by patience and subtlety. Unlike the jaguar that announces itself with power, or the anaconda that dominates with mass, the turtle exerts influence quietly, through migrations, through the dispersal of seeds, through the shaping of sandbanks and river corridors. It is not a hunter, nor an architect, nor a tyrant. It is a vessel, a living ferry of nutrients and life, carrying fragments of the forest within its gut from one bank to the next, linking ecosystems across distances far greater than its slow body suggests. Basking is more than rest for these reptiles. Being ectotherms, turtles rely on the sun to fuel their metabolism. Hours spent absorbing warmth translate directly into energy for movement, digestion, and reproduction. The log becomes a solar station, its surface occupied by a hierarchy of individuals, larger adults staking prime spots, juveniles pushed to the margins, the weakest left tootling to edges where a slip means exile into cold water before the body has reached full operating temperature. Thermoregulation here is not merely a physiological necessity, but a competition, one where access to heat can mean the difference between reproductive success and wasted potential. From this perspective, basking logs are not just resting places, but contested arenas, invisible battlegrounds in the slow war of survival. Every year, when the river recedes after the floods, these turtles perform a pilgrimage that has shaped the natural history of the basin. Hundreds of females gather on exposed sandbanks, their shells packed so densely that from a distance they resemble a moving carpet of stone. They dig with flippers, carving shallow chambers in the sand, and deposit clutches of eggs in synchrony. This mass nesting is a strategy born of numbers. No individual mother can protect her offspring, but by overwhelming predators with abundance, some fraction of the young survive. Yet the gauntlet awaiting these eggs is merciless. Vultures patrol overhead, swooping down to plunder freshly laid nests. Jaguars patrol the river edges, pawing at the sand with uncanny precision. Humans, too, long familiar with the seasonal bounty, harvest eggs as food. reducing hatchling numbers even further. For the turtles, reproduction is not guaranteed success, but a calculated gamble, a reminder that persistence through millennia comes not from invincibility, but from resilience in the face of attrition. Despite the predators, enough hatchlings emerge to sustain the lineage. When the first rains soften the sand, tiny turtles break free from their shells and scramble toward the water. Few make it. Herons pluck them up like candy, fish snap at them from the shallows, and caimans lie in ambush, jaws gaping. Of hundreds of eggs laid, perhaps 1 or 2 hatchlings will survive to adulthood. Yet this is enough. The species has endured for ages, not because most individuals live, but because a few always do. Their shells grow harder, their reflexes sharper, and in time they join the mass of adults once more on the basking logs. The turtle's role in the ecosystem extends far beyond the drama of predation and nesting. Unlike carnivores, which redistribute energy through kills, turtles shape the forest in subtler ways. They are omnivores, consuming a wide variety of fruits, seeds, and aquatic vegetation. Many of the seeds pass unharmed through their digestive tract, carried in their gut for kilometers before being deposited along distant banks. Some seeds even germinate more successfully after this passage, their tough coatings softened by digestive acids. In this way, the turtle becomes a silent gardener, planting forests not with intention, but as a byproduct of feeding. While monkeys scatter seeds in the canopy and bats carry them over long distances, turtles transport them along the arteries of the river, a dimension of dispersal that bridges aquatic and terrestrial realms. Without these ferries, certain plant species would remain confined, unable to expand their reach across the river's shifting geography. Their influence does not end with seeds. By burrowing into sandy banks for nesting, turtles churn and aerate the substrate, preventing compaction and allowing plants to establish roots. Their abandoned burrows become refuges for insects, crabs, and small reptiles, creating micro-habitats in otherwise exposed terrain. In this sense, turtles act as inadvertent engineers of riverbank stability, reducing erosion and anchoring sandbars that would otherwise be swept away. The presence of their colonies thus secures not just their own future, but the structure upon which other organisms depend. Life in the river, however, is a constant negotiation between past and present. For millennia, turtles moved through these waters with little interference, their cycles tied only to the pulse of the flood. Now human influence weighs heavily. Egg harvesting, though traditional, has grown unsustainable in some areas. Fishing nets entangle adults, drowning them before they can surface. Sandbanks are disturbed by boats and dredging, reducing the safe spaces for nesting. Climate change alters flood regimes, disrupting the delicate timing of reproduction. The turtle, for all its resilience, now faces a pace of change that evolution never prepared it for. Conservation programs, including protected nesting beaches and community-based egg guarding, attempt to restore balance, but the outcome is still uncertain. What remains clear is that without these reptiles, the forest loses one of its most effective seed dispersers, a quiet but vital courier of life. The turtle's silence is part of its survival strategy. It does not roar or display like other animals. It does not defend territory with violent encounters. Instead, it withdraws at the first sign of danger, slipping into the anonymity of the river. Yet this silence is deceptive. Each turtle carries within it the seeds of dozens of plants, nutrients recycled from one bank to another, subtle engineering of soil and sand. Its movements may be slow, but the consequences ripple outward, shaping forests, feeding fish, and stabilizing the landscape. The river's corridors are alive because of these quiet ferries, linking environments with every mouthful, every journey, every nest dug into sand. On a humid evening, as the sky turns amber and the river darkens, the turtles return to their log. One by one, they hoist themselves from the water, claws gripping the bark, shells dripping. They settle into place, overlapping, aligned, silent. The herons drift by at a distance. The jaguar's tracks are washed away by the tide, and for a moment, the world is still. Yet inside their bodies, seeds lie dormant, carried from distant groves, waiting for the chance to root in fresh soil. The turtles may appear motionless, ancient relics basking in sunlight, but beneath that quiet exterior, they are agents of continuity, ensuring that the forest not only persists, but spreads and renews itself along the course of the river. They are not predators or prey alone. They are silent seeders, lifelines disguised as stone. A single leaf suspended high in the canopy tells a story invisible to the casual eye. Its surface is torn by a sequence of perfect arcs, each bite aligned with surgical precision. Flip it over, and the surgeon is revealed, a caterpillar clinging to the underside, its body colored in the same green as the leaf's veins, its motion almost imperceptible. For the forest, this tiny creature is more than a hungry mouth. It is an agent of change, a biological scalpel that prunes vegetation, tests plant defenses, and feeds an entire web of predators above it. In the rainforest, the caterpillar is both a victim and a manipulator, quietly shaping the structure of the jungle one leaf at a time. Caterpillars are the larval stage of moths and butterflies, members of the order Lepidoptera, and they are born into a world of chemical warfare. To the human eye, the forest may appear lush and infinite, but for an insect that eats only leaves, food is anything but straightforward. Plants, far from being passive, arm themselves with a wide array of defenses: bitter alkaloids, toxic cardiac glycosides, sticky latex that can glue jaws shut, even microscopic crystals sharp enough to tear internal tissue. The caterpillar's life is therefore a contest against chemistry. Each species is tuned to a narrow diet, specializing in a plant or small group of plants whose toxins it can tolerate. This extreme selectivity explains why the Amazon, with its staggering diversity of flora, also harbors a staggering diversity of caterpillars. Each new plant innovation spawns a new counter-adaptation, fueling an evolutionary arms race that has been running for tens of millions of years. When a caterpillar bites into a leaf, the damage does more than reduce photosynthesis. The injury itself triggers chemical alarm bells within the plant. Compounds surge to the wounded tissue, tannins accumulate, and volatile scents drift into the air. These scents are not just warnings to other leaves of the same plant. They are signals to the wider ecosystem. Predatory wasps, for example, home in on these chemical trails, following the airborne cues to find the herbivore responsible. Thus, a single bite can ripple outward, drawing hunters to the scene. In this way, caterpillars unintentionally dictate predator activity, their feeding habits becoming the starting gun for an entire cascade of ecological responses. What seems like a small act of consumption is in fact a trigger point for a network of interactions stretching across species and trophic levels. Survival for the caterpillar requires deception. Birds, bats, and wasps all see them as easy prey, so natural selection has driven caterpillars to become masters of disguise. Some mimic twigs, their bodies angular and brown, frozen in place even when touched. Others resemble bird droppings, mottled with white and brown, repelling predators with the illusion of waste. A few go further, bearing patterns that mimic snakeheads, complete with false eye spots that flash when the caterpillar is disturbed. To an approaching predator, these illusions can buy critical seconds, just long enough for the caterpillar to drop silently from a leaf or curl into a ball. Camouflage here is not decoration. It is survival, refined through countless generations of predation. The irony is that despite these elaborate defenses, the majority of caterpillars do not survive to adulthood. For wasps, caterpillars are both prey and hosts. Many species inject eggs directly into a caterpillar's body, their larvae consuming the host alive from within until they erupt as adults, leaving behind an empty husk. Birds pluck them by the thousands to feed their chicks, each mouthful translating into the energy needed for a fledgling to take flight. Bats sweep through at dusk, catching them in near darkness, using echolocation fine-tuned to detect the faint flutter of a struggling insect. In this sense, caterpillars are not just consumers of leaves, they are producers of energy for the ecosystem, the soft-bodied currency that flows upward through the food chain. Without them, many higher predators would falter. But to frame caterpillars only as prey is to miss their deeper role. By selecting which plants to feed on, they exert subtle pressures on vegetation patterns. Some species can defoliate entire saplings, ensuring that only the hardiest individuals survive. Others feed more sparingly, trimming leaves in a way that reduces plant vigor without outright killing. In doing so, they influence competition between plant species, preventing fast-growing dominance from overrunning the slower, more delicate flora. The forest that we see, its balance of species, its mosaic of light gaps and understory shrubs, is in part a reflection of these silent herbivores. They dictate what thrives and what falters, pruning the green architecture of the rainforest with countless tiny jaws. The caterpillar's physiology reflects this lifestyle. Their digestive tracts are long and efficient, designed to process cellulose, a molecule notoriously difficult to break down. Some harbor symbiotic microbes that help extract nutrients from fibrous tissue. Their bodies are essentially conversion engines, turning tough plant matter into soft protein that predators can readily use. Even their growth strategy is a reflection of their role. Caterpillars molt multiple times, shedding skins as they expand, each stage bringing a new pattern, sometimes even a new disguise. Their existence is temporary, but during this brief span they process enormous amounts of plant biomass. Estimates suggest that Lepidopteran larvae consume more vegetation in tropical forests than any mammal or bird, making them the true regulators of foliage abundance. When the time comes, a caterpillar undergoes its final transformation, pupation. The stillness of the chrysalis belies the storm within, as tissues liquefy and reorganize, forming wings, compound eyes, and reproductive organs. This metamorphosis is one of nature's great miracles. The leaf surgeon, the hidden grazer, is reborn as a pollinator. Butterflies and moths emerge not just as new creatures, but as new ecological actors, shifting from consumers of plants to distributors of their pollen. Thus, the caterpillar's life is not an end in itself, but a prelude, a stage that sets the foundation for future ecological service. The jaws that once dictated plant survival give way to proboscises that extend the life of the very plants once consumed. Yet even before that transformation, the impact of caterpillars is undeniable. They are the hinge on which multiple ecological doors swing: plant defenses, predator foraging, nutrient cycling, even the architecture of the forest canopy. To call them small is to misunderstand their scale of influence. Billions of them feed simultaneously across the Amazon, each bite shaping the trajectory of growth and survival for countless species. They are not just background life, they are agents of selection, invisible managers whose choices ripple outward through the entire system. As the day warms and sunlight pierces deeper into the understory, the caterpillar beneath the bitten leaf remains motionless. Its body aligns perfectly with the midrib, invisible to the casual eye. A wasp hovers nearby, antennae twitching, drawn by chemical cues released from the wounded tissue. For a moment, predator and prey exist in tense proximity, the outcome uncertain. Whether the caterpillar survives this encounter or becomes another link in the food chain, its influence is already imprinted in the leaf it has carved. The wound will heal, but the chemistry of the plant is now altered, its future interactions with herbivores and pollinators subtly redirected. This single insect, scarcely a few grams in weight, has already nudged the vast machinery of the rainforest. The caterpillar is a paradox, fragile, short-lived, and endlessly devoured, yet central to the functioning of the Amazon. Its legacy is measured not in the lives of individuals, but in the cumulative impact of billions. Each bite, each disguise, each metamorphosis contributes to the dynamic equilibrium of the forest. The leaf surgeon is at once predator and prey, sculptor and sacrifice, a reminder that even the smallest mouths can leave the deepest marks on the world. A blur of tan muscle flickers between trees, a ripple of movement swallowed by shadow. The forest stills in response. Capybaras wheel toward the river, their hooves churning mud. Howler monkeys bark alarms from the canopy. For a moment, all eyes search for a jaguar. But the silhouette that vanished into the understory was leaner, longer, and quieter. It was the puma, a phantom predator that does not roar, that leaves little trace, but whose influence stretches across every forest edge, clearing, and riverbank. The puma, Puma concolor, is one of the most widely distributed predators in the Western Hemisphere, ranging from Canadian Rockies to the southern Andes. In the Amazon, it occupies a paradoxical space, present everywhere, seen rarely. Unlike the jaguar, which dominates with bulk and brute force, the puma survives through adaptability. Its diet is astonishingly broad, encompassing everything from capuchin monkeys plucked during risky leaps to hefty capybaras hauled down at river margins to deer, armadillos, and even porcupines. Where prey is abundant, the puma thrives. Where prey vanishes, it shifts, subsisting on smaller quarry until conditions improve. This versatility has allowed it to persist in landscapes where other apex predators falter, making it both a generalist survivor and a specialist hunter. Its role in the ecosystem is defined not just by what it eats, but by what it prevents. Herbivores left unchecked can devastate the forest, stripping seedlings before they take root, overgrazing clearings, and destabilizing the delicate regeneration cycle that underpins the Amazon's resilience. The puma's kills are not acts of chaos but corrections, ensuring no single prey population overwhelms the balance. Every fallen deer represents 1,000 seedlings spared. Every capybara taken eases pressure on the banks where erosion waits to begin. In this way, the predator becomes a gardener in disguise, pruning animal numbers to allow plants to flourish. To accomplish this, stealth is everything. The puma is crepuscular, most active at dawn and dusk, when shadows stretch long and cover is deepest. These hours are not chosen only for advantage over prey, but also to avoid encounters with jaguars. Despite being smaller, the puma is not subordinate in skill, rather it is cautious. Jaguars are heavier, stronger, and fiercely territorial. A direct confrontation could be fatal. So the puma yields the brightest hours of night and deepest daylight to its larger cousin, slipping instead into the in-between, patrolling margins when the jaguar is less likely to appear. This temporal partitioning is an elegant compromise, allowing two apex predators to share the same territory without annihilating one another. In the silence of twilight, the puma moves as if it were smoke. Its padded paws spread its weight, muffling footfalls even on brittle leaf litter. Its body is streamlined, each muscle a coil of potential energy. Unlike sprinters, such as cheetahs, pumas are ambush hunters, relying on explosive power over short bursts. A deer grazing in a clearing may hear nothing, see nothing, until 100 kilograms of muscle slams from the undergrowth, jaws clamping on its throat. The kill is swift, efficient, clinical, and yet not every hunt ends in success. Studies show pumas often fail more than they succeed, their stealth compromised by wind, by sharp-eyed prey, or by the simple unpredictability of the wild. But survival is not measured in percentages. A single large kill can feed a puma for days, even weeks, during which it caches the carcass under leaves, returning to feed in intervals, its presence betrayed only by the scent of decay and the tracks of scavengers. These leftovers are more than scraps. They are resources redistributed into the forest food web. Opossums, foxes, vultures, beetles all feed from the puma's surplus. In this way, the predator's influence cascades outward, providing sustenance for species that could not claim such prey themselves. Even plants benefit indirectly, as nutrients from the carcass seep into soil, fertilizing new growth. The death of a capybara, gruesome as it may seem, becomes a pulse of life spread across multiple kingdoms of the forest. Pumas are solitary, each individual patrolling a home range that can stretch hundreds of square kilometers. Within this territory, the cat leaves chemical signposts, scrapes in soil, scat deposits, scent marks sprayed on tree trunks. These messages are not idle. They tell rivals where boundaries lie, warn intruders of presence, and perhaps even announce reproductive readiness. Though rarely seen together, pumas interact constantly through this chemical language, their invisible dialogues shaping movement patterns and density across the forest. Solitude does not mean isolation. It means a society written in scent rather than sight. Despite their adaptability, pumas live on a knife's edge. They are generalists, yes, but they depend on healthy prey populations. Habitat fragmentation, hunting, and human encroachment all diminish that prey base. In areas where herbivores are hunted heavily, pumas vanish soon after, unable to sustain themselves on rodents and birds alone. Where roads carve into forest, they face new dangers: collisions with vehicles, exposure to poachers, persecution by livestock owners. The shadow predator thrives only when the shadows themselves are intact. Remove the cover of forest and the phantom disappears. What makes the puma remarkable is its ability to thrive in landscapes of transition. It does not require pristine wilderness alone. It hunts along the edges of agricultural fields, in secondary forests, even near villages, always pressing against the limits of human tolerance. This adaptability, however, is double-edged. It brings pumas into conflict with people, their opportunism extending to goats, chickens, and calves. Where tolerance falters, retaliatory killing follows. Yet, ecologically, their presence is invaluable. Without them, herbivores multiply unchecked, and the cascade of overbrowsing spreads outward, eroding the very productivity humans depend on. In this sense, the survival of pumas and the survival of forests are intertwined, though rarely recognized as such. Their physiology mirrors their role as versatile hunters. Their bodies are compact but athletic, built not for raw strength like jaguars, nor blinding speed like cheetahs, but for balance. They can leap over 5 meters vertically, scale cliffs with ease, and swim across rivers when necessary. Their senses are finely tuned, eyes adapted to low light, ears that catch the faintest rustle, whiskers that gauge distance in darkness. Every feature serves the same end: to strike unseen, to vanish unheard, to persist without announcing presence. From the perspective of prey, the puma is a ghost. Deer alter their grazing patterns when puma scent is detected, moving more frequently, feeding less confidently. Capybaras shift from open sandbanks to crowded reed beds, trading sunlight for security. Even monkeys adjust, clustering in larger groups when traveling through areas marked by the predator. This phenomenon, known as the landscape of fear, illustrates the true power of the puma. It is not only the individuals it kills, but the behaviors it alters, the spaces it empties, the times it controls. Prey species live under the pressure of an unseen presence, and in responding to it, they shape vegetation and habitat use in turn. At dusk, the forest exhales as heat drains into the soil. Shadows lengthen, the cries of daybirds give way to the throbbing of frogs, and the puma begins its patrol. It slips between trees, silent as the falling night, its path invisible except for a fleeting disturbance among capybaras or a sudden silence among howlers. By dawn, it will have tested clearings, scanned trails, and perhaps made a kill. Whether successful or not, its passage leaves ripples in the forest fabric, redistributing fear, energy, and life. The puma does not need spectacle to rule. It does not roar or flood rivers with strength. Its authority lies in restraint, in its ability to survive by being unseen, to balance the system without tearing it apart. It is the quiet counterweight to the exuberance of herbivores, the shadow that ensures the forest's edges do not unravel. In its stillness, in its vanishing act, lies its power, and in its survival lies the balance of the jungle itself. In the pale light of dawn, a strange monument glows against the dim undergrowth. Rising from the forest floor, taller than a man and shaped like a weathered cathedral, the termite mound exhales faint tendrils of steam. The night's humidity, trapped in earthen spires, condenses in the first rays of sun, giving the structure the appearance of a living furnace. At its base, the soil is littered with fragments of chewed wood and leaf litter. From its surface, minute workers scuttle, carrying particles smaller than grains of sand, slotting them into place with a precision that makes the tower grow imperceptibly higher. To call this a nest is misleading. It is an engineered city, home to millions, sustained by tunnels that stretch deep underground, a superorganism that has been shaping this soil for longer than primates have walked upright. Termites are often dismissed as pests in human imagination, creatures that reduce beams to dust and houses to ruin. Yet here, in the Amazon, they are the very opposite. They are foundation builders. Their purpose is not destruction, but renewal. Every fragment of dead wood, every fallen leaf, every branch that collapses in a storm finds its way into the mouths of these insects. With specialized gut microbes, tiny symbionts capable of breaking down cellulose and lignin, termites perform what few organisms can: They turn the most stubborn plant matter into fertile soil. What humans see as decay, termites convert into continuity. Without them, the forest floor would choke under its own detritus, nutrients locked away, unavailable for new growth. The cathedral mound is only the surface signature of this hidden empire. Beneath the soil, termites carve labyrinthine galleries that extend for meters, sometimes linking multiple mounds into sprawling subterranean complexes. These tunnels are not random burrows. They are climate-controlled passageways designed to channel air and water through the system. Some species orient their mounds with magnetic precision, aligning the spires north to south so that sunlight warms one side in the morning and the other in the evening. This thermoregulation maintains stable internal temperatures despite the extremes of tropical heat. Inside, brood chambers, fungal gardens, and royal quarters are maintained at conditions as precise as any laboratory, all regulated by the ceaseless labor of workers, no larger than grains of rice. The architecture of termites serves the forest as much as themselves. Their tunnels hydrate the soil by channeling rainwater deeper than roots alone can reach. Their constant mixing of organic and mineral layers aerates compact ground, preventing suffocation of roots and enhancing nutrient cycling. Studies reveal that forest patches with dense termite activity recover faster after drought or disturbance, the soil more resilient, the seedlings more robust. In this way, termites act as ecosystem stabilizers, invisible engineers, ensuring that the rainforest remains productive even when stressed. But termites are more than decomposers. They are farmers in their own right. Certain species cultivate fungi inside their mounds, carrying spores from parent colonies and feeding them with chewed plant matter. The fungi break down cellulose, rendering it digestible, and in return the termites harvest the swollen fungal nodules as food. This relationship, refined over millions of years, represents one of nature's earliest experiments in agriculture, long before humans planted fields. It demonstrates the principle that runs throughout the rainforest. Cooperation across kingdoms can be more powerful than competition. Where there is abundance, however, there is also vulnerability. Termites' ubiquity makes them a cornerstone prey for countless species. Tamanduas rip open their galleries with curved claws, their sticky tongues scooping workers in rhythmic sweeps. Birds like wood creepers pry into the soft bark of infested trees, extracting termites in rapid strikes. Lizards probe tunnels, while frogs linger at entrances to ambush escaping workers. Even mammals as large as armadillos depend on termite colonies as steady food banks. In this sense, the insect's productivity is redistributed through the food web, supporting animals far larger than themselves. The termite colony may lose thousands in an attack, but the superorganism continues, resilient through sheer numbers and redundancy. Despite their small size, termites exert influence over forest structure at a continental scale. Their mounds alter local topography, creating raised islands of nutrient-rich soil. These mounds often support different plant communities than the surrounding forest, harboring species that thrive in drier or better aerated substrates. Over decades, these patches become hotspots of diversity, microhabitats that enhance the overall richness of the ecosystem. For some plants, termite mounds act as launch pads, the only places where seedlings can survive in flood-prone floodplains or drought-prone uplands. Thus, the insect's engineering reshapes not only soil chemistry, but also the very composition of the forest's vegetation. The social structure of a termite colony is as remarkable as its architecture. At its heart resides a queen, swollen with eggs, her body stretched grotesquely by an abdomen that produces thousands of offspring daily. Around her, kings and workers tend with unceasing diligence, feeding, cleaning, and defending. Soldiers, armed with enlarged jaws or chemical nozzles, guard entrances against intruders, ready to sacrifice themselves in battles that last only minutes but determine the safety of millions. This organization is not guided by central command but by pheromones and instinct, a decentralized intelligence that allows the colony to function as a single organism. The forest may teem with life, but here, beneath the soil, it is life organized, regulated, and inexhaustibly productive. What is perhaps most extraordinary about termites is the scale of their recycling service. Each colony processes tons of plant material every year, transforming wood that would otherwise resist decomposition into humus that feeds new growth. Multiplied by millions of colonies across the Amazon, their effect is staggering. They are the engines that keep carbon, nitrogen, and phosphorus moving, preventing the forest from stagnating under its own biomass. Every towering tree owes part of its growth to the silent labor of termites, whose unseen jaws released the nutrients that fed its roots decades earlier. Yet, like so many keystone species, termites are not immune to change. Deforestation disrupts their delicate networks, exposing soil to desiccation and breaking the continuity of tunnels. Fires incinerate their mounds, collapsing chambers that took decades to build. Even climate change exerts pressure. Prolonged droughts alter soil moisture, threatening colonies whose survival depends on hydration balance. And still, termites adapt. Colonies re-establish in secondary forests, rebuild after burns, and persist even in degraded landscapes. Their resilience mirrors their ecological importance. When termites vanish, ecosystems collapse, but when they remain, recovery begins. Seen in this light, termites are not minor background players but foundational engineers. Their architecture, their recycling, their farming, their role as prey, all combine into a systemic function that underpins the rainforest itself. The forest canopy may draw the eye with its brilliance of birds and monkeys, but it is the soil, turned and enriched by termites, that sustains the whole. To walk through the Amazon without acknowledging termites is to admire the roof without seeing the foundation. As the morning sun climbs higher, the termite mound ceases to steam. Workers retreat from the surface, slipping back into their climate-controlled galleries. From the outside, the structure appears dormant, a clay relic abandoned to the forest floor. But within, millions labor without pause, dismantling wood fibers, tending fungi, carrying soil grains in endless circuits. The silence is an illusion. The mound is alive, and through it, the forest breathes. The surface of the backwater lies undisturbed, a mirror of green canopy and broken sky. Cicadas drone from the banks, herons stand motionless in the shallows, and dragonflies stitch erratic patterns over the glassy sheet. Then, without warning, the water erupts. A column of liquid surges upward, splintered by a thick coil that rises, glistening black-green in the sunlight. Caught in its grip, a capybara thrashes, its squeals muffled by the slap of waves. The struggle lasts seconds, not minutes. With each loop of muscle, pressure builds, ribs bend, lungs collapse. The dark coil tightens, then holds, waiting for the pulse beneath fur to flicker and fail. Only when the beating heart stills does the giant snake relax, jaws sliding forward to engulf its prize. This is the green anaconda, Eunectes murinus, the heaviest snake on Earth and one of the most formidable predators of the Amazon. Though it may not rival the reticulated python in sheer length, No serpent surpasses its girth or mass. An adult female, often larger than any male, can exceed 6 meters and weigh over 200 kilograms, her body thick as a man's torso. Such bulk makes her presence undeniable, yet paradoxically, she is rarely seen. The anaconda is an animal of ambush and concealment, sculpted not for spectacle, but for invisibility. In the flooded forests and oxbow lakes of the Amazon basin, she is less a snake than a shadow beneath the surface, a phantom of the floodplain. Unlike tree boas or ground-dwelling vipers, the anaconda is supremely aquatic. Its eyes and nostrils sit atop the head, allowing it to breathe and watch while almost completely submerged. Muscular loops anchor against submerged roots, permitting hours of stillness without drift. A patient hunter, it does not stalk across distances, but waits, motionless, until prey draws too close. Fish, birds, turtles, caimans, capybaras, all are vulnerable once within reach. When the strike comes, it is sudden and explosive. Jaws armed with dozens of recurved teeth seize the victim, while the body whips around in coils that lock with hydraulic inevitability. For years, people imagined that constrictors killed by suffocation, squeezing air from the lungs of prey. But research has revealed a subtler truth. The anaconda's coils are sensitive enough to detect the faint rhythm of a beating heart. With each pulse, the snake tightens, restricting blood flow until circulation halts. The victim loses consciousness in moments, death following quickly thereafter. This method is both efficient and secure. No thrashing mammal can outlast the silent calculation of a snake that knows when the heartbeat ends. Such hunting success permits an extraordinary lifestyle. A single large kill can sustain an anaconda for weeks, even months. Its metabolism slows after a heavy meal, the body sinking into torpor as digestion proceeds. During these intervals, the snake seems to vanish, buried in weeds or settled in deep water, a presence more geological than animal. Seasonal fasting is common. In lean times or during the breeding season, females may forgo food entirely, relying on fat reserves accumulated from previous kills. In the ecology of the floodplain, the anaconda is less a constant consumer than an intermittent shock, rare but decisive, suppressing prey populations in bursts rather than continuous attrition. This pattern of predation has consequences that ripple across the ecosystem. Capybaras, prolific breeders and voracious grazers, might otherwise dominate riverbanks, eroding soil and stripping vegetation. Turtles, were they unchecked, could deplete aquatic plants and destabilize seed dispersal. Even young caimans, though predators themselves, are vulnerable to the coils of a larger anaconda. By regulating these species, the snake maintains a dynamic equilibrium along water's edge. Its role is not unlike that of the puma on land, not an omnipresent killer, but a subtle governor, ensuring that no single population tips the system toward imbalance. The body of the anaconda is a marvel of adaptation to this life between water and land. Its skin, patterned in olive and black rosettes, disappears against the dappled reflections of sunlit water. Muscles run in staggered spirals, distributing power along the entire length of the body. Unlike most snakes, the anaconda is an adept swimmer, able to move with silent undulations or anchor itself for ambush. Its lungs extend far down the torso, functioning as ballast tanks that allow buoyancy control. It can hold breath for 10 minutes or more, surfacing only briefly to inhale before sinking again into its phantom state. Reproduction brings its own spectacle. In the early wet season, males track pheromone trails through flooded forests, converging on a receptive female. What follows is a phenomenon almost without parallel: the mating ball. A single female, far larger than her suitors, may be encircled by a dozen males, each twisting and pressing, competing for the chance to align cloacas. This writhing knot can last for hours, even days, the female sometimes submerged beneath the collective weight. Curiously, females often emerge with little interest in feeding afterward, subsisting for months on stored energy as developing embryos grow within. Unlike most reptiles, anacondas give birth to live young, dozens of wriggling neonates dispersing immediately into the shallows, each already an independent predator. Survival rates are low, but the numbers ensure that some endure. Beyond their biological presence, anacondas loom large in human imagination. To local communities, they are not merely animals, but mythological beings, woven into folklore as guardians of rivers or manifestations of ancestral spirits. Tales speak of giant serpents dragging cattle into swamps, or of mothers warning children not to swim at dusk lest the water spirit seize them. While exaggerated, these stories reflect the awe such creatures inspire. For those who share the floodplains, the anaconda is not simply a snake. It is a reminder that water, though nourishing, also harbors power beyond human control. Yet, as with so many Amazonian inhabitants, the future of the anaconda is uncertain. Habitat destruction shrinks its wetlands, dams alter flood cycles, and hunting persists in some regions, driven by fear or by the trade in skins. Though resilient, the species is slow to reproduce compared to smaller reptiles, and large females, the most important breeders, are particularly vulnerable when killed. Conservationists emphasize that protecting anacondas means protecting entire wetland systems, oxbow lakes, swamps, and floodplains that sustain not just snakes, but birds, fish, amphibians, and human livelihoods as well. Still, the anaconda endures. In remote waters, far from the sound of engines and axes, it waits as it has for millennia, silent and unseen. To watch the river without noticing it is easy. To know that it may be watching you from below is something else entirely. Every ripple, every sudden silence of frogs, every hesitation of capybaras on the bank hints at its presence. By evening, the water is glass again, cicadas still droning, herons still poised. The capybaras return warily to feed, their eyes scanning the shallows. Somewhere beneath them, coils rest anchored in weeds, the phantom reset, patient as stone. It will not strike tonight, perhaps not for weeks. But its shadow governs the riverbank all the same, a top-tier regulator whose authority lies not in frequency, but in inevitability. The anaconda does not just kill, it enforces respect. At the edge of water, every creature measures its movements with the phantom in mind.